Okay, so we're now going to look on to the factor theorem, and the factor theorem is just an extension of the remainder theorem, really. It's for a specific case. Now, if the divisor is a factor, remember we said the x minus a was my divisor. Now, if that's a factor, there will be no remainder, because that's just the definition of division. You know, 2 goes into 4, there is no remainder. 2 is the divisor. So there is no remainder. So it means it goes exactly. So so when I substitute the value of a, if x minus a is a factor, I'm going to end up with no remainder. So the value of the equation is just going to be 0. So here we go. Here's the proof again for those looking at doing the excellence type work. So given that p of x is x minus a, the quotient, so the divisor and the quotient plus the remainder. If it's a factor, then we know there is no remainder. So that can just go straight away. So I put in, so p of x just now becomes x minus a times the quotient. If x equals a, p of a is going to be a minus a times the quotient. A minus a, obviously 0. So the quotient then goes through multiplying by 0, and we get p of a equals 0. Now there are 2 types of questions they can ask you on this. The first one is just showing that x, in this case, is showing that x plus 2 is a factor of this cubic. So again, all I do is I take the minus 2 from the factor. I look at the factor and say, right, x is going to be minus 2. Substitute it all in, and you can follow the calculations through to see that it is 0. So therefore x plus 2 is a factor of that particular polynomial. Another type they will ask you is that they will put an unknown coefficient in the equation. They'll tell you that something is a factor, and therefore you have to work out the coefficient. So here we go. So we told that 3x plus 1 is a factor of this cubic here, 3x cubed plus 7x squared minus kx minus 8. So there's my unknown, and my objective is to find k. Because I know it's already a factor, I can immediately say it's equal to 0. Okay. Substitute in for this case, it's going to be negative 1/3. So I get 3 times negative 1/3 all cubed, plus 7 times negative 1/3 squared, minus k times negative 1/3 minus 8. Okay, evaluating all of that out, and that's just simple arithmetic to show you that ultimately k ends up being 64/3.